there's a few things we haven't touched on. More complex data preparation. I've got a typo in here, which I can fix and demonstrate the markdown at the same time. You can see I switched to markdown mode and then back to rendered mode. So we might want to do more complex data prep and pre-processing, like de-skewing and encoding categorical variables. It would be nice to play with other algorithms if we had more time. We would look at things like tuning and cross-validation of models, how to combine Spark with other tools like scikit-learn and TensorFlow, because that's really important. Not everything in the world is going to just be inside Spark. We want it to work in a performant manner with other tools. How Spark actually does these model building jobs in parallel, and how to extend Spark ML. So Spark ML is meant for you to extend if you want to with your own feature engineering transformers and estimators and even your own algorithms. So it's not a closed box. You don't need to hack on Spark code. You can kind of plug directly on and add your own pieces. So we've got about 5 or 6 minutes left, and I want to use that just to give you a very quick look at one of the areas of the most recent development in Spark, and that's structured streaming. So this is a way of looking at streaming apps as if they are just tables that keep growing. It makes it much easier to think about streaming because you just think about it as an append-only table, and you can use all of the stuff that you've learned and built for data frames and SQL to work over streaming data. In this example, we're going to look at real-time edits, like actually real-time right now, into Wikipedia. And we're going to kind of take a look at who's editing the Wikipedia in which languages. So this first command, again, there's no Spark here. This is just showing you what the data stream looks like. You can see that it's JSON encoded, and it has a bunch of information about each edit. So like what language and where the edit's coming from, obviously what article is being edited, who did it, and so on. I'm going to make a little tuning adjustment to Spark here because there's not that much data in this stream. So I want to kind of change the parallelism a little bit. And then what I want to do is write our first streaming program. And it's very straightforward. It's modeled on the data frame pattern, but instead of saying spark.read, I say spark.read stream. In this case, I'm reading from a socket. That socket is providing data from this particular host and port. And then I need to parse the JSON. So I'm going to do a select. I'm going to use a built-in function called JSON tuple to decode the value column that contains the JSON and extract these other columns from it. So channel, which is the language, timestamp, is robot, and is anonymous. And when I run this, you can see that I actually get a plain old data frame out. So the system is really unified underneath, and we really do view this data as a data frame. It's all one big system. If I call display on this, we'll be able to see these updating in real time. See, if I hover over the squiggly line here, you can see what it's doing. It's processing data, and now I've actually got a bunch of edit data streaming in here. And every time it gets more data, it's kind of updating the view on the screen. So I'm going to stop that. And I want to show something a little bit more complex that's also maybe a little more useful. So we wanted to count the edits that are coming through in the different languages and kind of compare those. So I have an example that does that. I've got a couple examples. We only have time for the first one, but I think that will give you an idea. I'm going to read the data the same way I just did. I'm going to decode it the same way I just did. I'm going to adjust the columns a little bit, like I'm going to give them some nice names, and I'm going to convert the timestamp column, which is originally a JSON string, into an actual Unix timestamp. And I'm going to give it a table name called edits. And there's just a demo that we can combine all these things. I'm going to use spark.sql to do a regular SQL query that counts the edits and groups them by channel and time. And then I'm going to write these out to a buffer so that we can take a look at what's happening. So at this point, we have data flowing through the system. We can't see it because we're writing it to a buffer, but what I can do is I can query the table that I created above, which is called demo. And whenever I adjust this or refresh this, you'll be able to see the very latest data coming through. So this is showing the number of edits at each of these 1 second timestamps across the different languages. Now, if we had more time, the next example that I would do would be to look at how we can kind of bucket these over wider time intervals. Because when you look at this, there's a lot of noise in there, right? We're comparing edit counts per second. And that's maybe a silly way to do it. So in real life, we probably want to look at edits every 10 seconds or every minute. So if we had more time, that's what we would do. We don't have more time today, so I'm not going to. But I'm going to turn off this streaming job. And the very last thing I'm going to mention here is that with Spark 2.3, for the first time in the history of Spark, we have a low latency or millisecond latency continuous streaming mode. Historically, Spark did streaming only in micro batches, which is actually really great for a lot of applications. But Spark also supports continuous processing now with millisecond latency, which is key for a lot of business use cases. So to wrap up, we've gotten kind of a tour of all the major areas of Spark and some of the tooling here. And the common use cases for Spark for most businesses are batch ETL jobs, batch or ad hoc analytics, data visualization, building machine learning and scoring data using machine learning models, streaming applications that combine all of these. You can have streaming ETL, machine learning, or analytics apps, and also graph analysis using some other add-on APIs that we haven't seen today, all with high performance and linear scalability. So that's pretty much all we have time for today. I hope this is useful for everyone as an overview.